So for this next expression, it's not quite as simple. I'm giving you an exponential expression, however the bases are not the same. Okay, you see, notice there's a 2 and there's a 16. Well, those bases aren't the same, so you do have to do a little work first. This has nothing to do with logarithms yet. You need to remember that 16 is a power of 2. 16 is 2 to the 4th power. And I'll show you a way around that with logarithms. We don't have to do this problem this way. There's other ways to do it. But this is the fastest way. Okay, you can always use a calculator, but I'll show you the logarithmic process in another example. So if you can get the bases to be the same, you can basically just cancel them off. You got to remember there's a 1 up here. Okay, so you end up with this equation to solve. You might as well distribute because you're going to have to. So then subtracting the 8 gives you negative 7 equals 4x. You divide by 4, you get negative 7/4 equals x. If you prefer decimals, that's fine, but fractions are okay as well. Okay, so I'll give you one more like that. So before we get to the more complicated ones. So if I asked you to solve this one, let's go with 9 equals 27 to the x minus 4. So again, the bases are not the same. We have a 27 and we have a 9. So the challenge really is that you remember that those are both powers of 3. 9 is the same as 3 squared. 27 is the same as 3 to the 3rd. And you leave that x minus 4 up there. Okay. Now if you don't remember that, don't stress out too much. You can use a calculator, and I'll show you the process to avoid that if you wish to. Okay. So now we made the bases the same. They're both 3. So you can go ahead and solve what's left. So I'm going to add 12 to both sides. That gives us a 14 over there. Divide by 3. So x equals 14/3, I think, is the best answer. But if you want to do a decimal, that's fine. I think it would be 4.66 repeating.